This is the empty account manager program which I've shipped for you to all take a look at and steal bits from. If you've got any doubt about where things are supposed to happen and what elements are supposed to do what things, then you can have a good hard look at my code and use it as the basis for yours. It's not complete. There are some behaviors which are missing, which is kind of intentional. I haven't got any stuff about age and annual income checking, and the create new account button at the moment does nothing because you did that code last week, right? So what you can do is take your code and drop it into my solution, or vice versa, don't mind which way particularly. When you open up my program, you'll find there are a bunch of buttons. If I try and search for account number 1, we're gonna, oh gosh, can't find him. Oh, wrong one, sorry, brain not working. If I try and search for account number 1, then I find my friend Dit, because I've got a behavior inside my bank that makes a test bank, which I'll show you in a second or so. But along the bottom, we have the red lab buttons, which I've set up for you. This one says test load and save. If I press that, it says it's failed. If this one says account toString, if I press that, it just comes up with a placeholder. This one says bank toString, and it does the same. And then this guy here says bank equals, that also fails. And this guy here says account equals, and this guy fails as well. What I've done, yeah, I know about that, you're rubbish. What I've done, we look at the code now. We drop into the actual main menu. This is not a particularly good way to do it. I'll do some stuff on formal testing later on this semester, but for now I wanted to provide a way in which you can test these fundamental behaviors without having to use the console, because the console is a bit of a pain in this respect. So these buttons are all bound through to the behaviors which I want you to implement. So if you press the test account toString button, the click event handler runs, it makes a new account and then tries to get the toString. If you do the same with the bank, as a bank one, sorry, and an account one, which do the toStrings for those two guys, then I have a test for equals. I make two accounts and I put them in the bank, and then I see if the two banks contain the same stuff. I do the same thing with accounts. And so what I want you to do in the lab is basically fill in the toString and the equals behaviors for accounts and banks, so that all these, you're going to keep telling me this rubbish all the time. Maybe. Okay, so I'm going to basically ask you to fill in those blanks and get we talked about toString and equals last week. They're in the labs, and they're in the notes from last week's lectures. So have a look at what those have to do. And the lab basically says, fill it in so that all these red test buttons actually work, and then add an overdraft value to the account, which can be managed in the same way as everything else. So you have to do the whole workflow of putting it into the form, binding some buttons to events to deal with it, writing some helper methods in the XAML behind code, and then writing the actual property behaviors, or have you tried to do it inside the account class, and make the save and load work for it too. Does that kind of make sense? The idea is that the XAML, for those of you that are a bit confused about this, the XAML contains a screen design, so it tells me where things go. The buttons, and there are quite a few now, these guys here and also these guys here, actually trigger actions which the account class will perform for us, or whatever. Go away. And so what we have, if we look at the code behind, is when I press the button, something happens, and the rule of thumb is that the account and bank objects are the things that do the work, and all the XAML does is actually connect through to those. So when I hit create account button .click, at the moment nothing happens, but what I would do in my finished version is fetch the age fetch the income, ask the bank if it's okay to ask the account, hey, can we have people with this kind of income and this kind of age? If the account says yes, then we build the account and try and create one and put it in the bank. Otherwise, we don't. So you'll have to fill that in, and then you'll have to fill in the other ones underneath there to make the tests work. Does that kind of make sense? Any questions on that? The thing I think that is neat about this is that, yeah, the thing that's neat about this is that what we have made will work for anything. It'll work for banks, record collections, clubs, you name it. You have a system, a template, where you can make any kind of data-driven app. And I kind of like that, and you'll kind of like it too, because you'll find that the SS coursework, which is coming out hopefully end of this week or early next, has as one of its projects a line of business app. So this is a good starting point, and it does pretty much all of it. If you look at the actual bank class, you'll find that I've actually got, there's my make test behavior, and all it does is you tell it how many customers you want. It makes an empty bank called test bank, and then for how many customers you've asked for, it makes a test account and adds it to the bank. So we use my test account behavior to fill the bank full of accounts. I can make as many, I could put 1,000 in it. Just ask for 1,000 accounts, I get 1,000 accounts. Isn't that lovely? The save and load behaviors are lifted straight out of the slide deck, or perhaps it went the other way, I can't remember. So we have a load for the bank and a save for the bank. We have the load that loads, the save that saves to the text stream, the save that saves to the file name, the load that loads from the text stream, and the load that loads from the file name. They're all there, and it all just works. So you can play with that and find your way around it, and then think seriously about stealing that kind of code. I'm going to tell you now how save and load works, though, if you're not quite sure. So pin your ears back. Let's crack on with that. Before I do, any questions? Oh, okay. I like that. It's good. So, I'm wondering we should go, yeah, so slideshow from beginning. Saving and loading. Right. You've got the code to do this, but I'll tell you how it works because I'm nice-ish. Dictionaries are variables inside my program. When the program stops, the variables vanish, the data disappears. This is bad. We've kind of got round this problem in the short term by making test stuff every time we start it up, which is fine, that works okay, but I want to use files. Now we did files last semester, yeah, that worked quite well. So we need to find a way of doing this. In terms of my view of the bank, we'll start up, we'll open up a bank and load it into memory, we'll work on it, and we'll save it back out of memory when we've finished. So it'll be a little bit like Word, in that we'll load up a document and then save it back at the end. That's how I see it working. If you dig into XAML and Windows WPF and whatnot, you'll find it's actually quite easy to bind to events that fire when the program starts and also when the program's being closed. So what you can do is make the save and load behaviors invisible as far as the user's concerned. So when they start the program, it brings in the data. When they leave the program, it saves it back again automatically. And so take a look at that. It's kind of like a nice way to do it. But in terms of the sequence, it's like every other program we've ever used, pretty much. Bring some data in, work on it, save it back again. That's all good. Now, we know how... Do you remember writing to a file? Streams and all that? Earth calling the first year. I did teach you, didn't I? It wasn't just an awful dream. You can do stuff like, let's write to a file from scratch. Let's make a new project. Oh, will you stop telling me that? A console app called File Demo. Okay. Now I'm going to just knock this out really quickly from memory because I am that good. Using, see, system.io. All the file I/O stuff lives in the I/O namespace inside system. And so now in here I can go stream writer s equals new stream writer, and we'll point it at a file which we'll call test.txt. Okay, why did that thing go there? Oh, dear. So look at me, I've got a stream writer, isn't that good? Now I go s.writeLine. This is going in a file. Right, okay. WriteLine is kind of familiar because it's how we write to the console, correct? Then, having done that, I go s.close. Look, shut up. Stop being funny. Every now and then, for reasons that can't be adequately explained, OneDrive goes, every single file on your machine is invalid, all 21 gigs of it. So it then goes online to compare it all with the original that hasn't changed. And so you use a ton of bandwidth and a lot of processing power and a lot of battery, and you get nowhere. Discuss. Very strange. s.close. So there you go. That's a file writing program in its simplest form. If I run this, it will work. Yay! And do nothing. So if I go into my desktop, which is where the project lives, and I go into File Demo, and I go into File Demo and look in the binary directory, then inside here is a file called list test, and there it is. This is going in a file. Wonderful. Not worth a round of applause, but then again, what is these days? So that's 3 lines of magic that will write a file for you and close it. The thing I'm interested in just mentioning at this point, because it's really important, is this thing called S. S is a stream writer. It writes to a stream. Fantastic, that works fine. Console is a stream writer because all the commands I use with console work on the stream as well. So I can write a little bit of text using write, or a whole thing using WriteLine. If I want to read it back, and why wouldn't I? You'll never guess what I use. I use a stream reader. Stream reader R equals new stream reader. Let's point it at the same file. And then in here, you'll never guess what I'll use. Yes, I'll use r.readline. If I can spell it. Apparently I can't do readline. There you are. So I can ask it for a line. It's best if you put the answer somewhere. So I'll go string line equals read it in. Console.WriteLine line, and then r.close, because I'm a good boy and I always close my files. So the program will now run, put a line of text in a file, close it, open it again and display it on the screen. Put a breakpoint here. Bam. Have a look. It's read it back. This is going in a file, so it obviously works a treat. Everyone okay with that? 3 lines of magic that write to a file. The thing I'm most concerned about is these guys, Mr. S and Mr. R, because they are like an object, a block of data, which describes a connection between a program and a file on the disk. So I can treat this thing as an object I can hand out. So, and this is how the save's going to work. We're going to give a method, a stream writer, and say, hey, write yourself out on that stream, please. And the object will go, yeah, fine, I can do that, bang, and just do it. And then when we read it back, same thing. We're going to give an object to the method that's the stream it can read from. Now, this is kind of, well, I'm okay with it. Integers hold integers, floats hold floats, strings hold strings, stream things hold, well, a definition of a connection to a file. I've no idea what's in there. I don't really care. It's a black box as far as I'm concerned, but I can pass it round and hand it off to other methods. Does that kind of make sense? Do you want me to show you what I mean? Yeah, let's do that. Whack in a static method called no static void writer, which is given a stream writer. Now that's a writer, please, called, I don't know, call it S again for reasons demo, and I can go S dot write line. This is from the method. Okay? And in here, rather than doing that one, which I will comment out for now, this is the bit you've got to get, because if you don't get this bit, everything else is built on sand. I can now go writer S like that. And so the actual writing is performed inside this method. So when I run the program, what will it display? It will display, this is from the method. Please. Well, hey, see? So the thing I want you to take away from this particular chunk of discourse is that I can pass my streams around as parameters to methods. So writer, it doesn't, I mean, I could pass it a connection to any file I like. Writer doesn't care what the file is it's writing to. Writer is given the stream and just works on it. So the whole basis of my save load behavior hinges on the fact that I can give a method a stream and say, hey, write yourself on that. Make sense? It's a nice piece of design. Once you've got that little piece of magic, everything else starts to come along very nicely. So we're writing save behaviors for, let's try and get the thing back. Beep. Not sure why you're determined to show yourself. I'll just move you out of the way. I'll get the mouse to work. Better? No? Try again. That's it, jolly good. Right, so. Yeah, it's got focus. Okay. Yeah. Gotcha. No. Try again, Robert. Robert is having a bad day today. Indeed, so he is. Let's try from current slide. Yeah, so we've done this writing to files now. I'll put that code up on SharePoint, all 7 lines. Now we're going to use it to save accounts and banks. And this is really important. I say that about 15 times every lecture. From a responsibility point of view, you have to farm the work out to where it needs to be done. The only person that can save an account is an account. The only person that can save a bank is a bank. Now the idea is, and you will spot this in the lab, if I design my account correctly and I build my system correctly, I can change what's in the account, but I don't have to change what's in the bank. Because the bank just says to the account, hey, save yourself. Or, hey, read yourself from this stream. And the bank has no idea or involvement in that process. It just asks the other object to do its thing, loading and saving, and that object gets on with it. So the idea is that we put the save and load behaviors specifically inside the objects which deal with them. If you think about it, it has to be that way because all the stuff in the account is private. So the only thing that can actually write an account really is the thing which is actually inside the account class. And in terms of reading it back, that goes double because you really can't set values inside the account class without being in there. So the save and load behaviors live inside the classes that hold the data that we're managing, which is fine. So here's my first account save method, dodgy code number 1. I give it a stream. I've called it a text writer rather than a stream writer. This is not really an important distinction. You can use either. I should probably change that to stream writer. Text writer is more abstract. Do you know what more abstract means? You have to think hard about it, yes. It's more abstract. I can write, turns out I can write to other things than streams. I can write to network connections and all kinds of other bits and pieces. And so the idea is that text writer is more abstract than streams, so I can feed other things in there than just streams. But streams work fine. So I don't even know why I mentioned it. There's my calls of write line. Write the name out. Write the number, the name, the address, and the balance. And they all go out on separate lines. Is everyone okay with that? What happens if something goes wrong with my writing process? It'll blow up. One of these guys, thing about writing to text files is that it can go wrong. If you've unplugged the USB drive before we try and do the write, if the network connection goes down, its network drive, that can go wrong. If the hard drive is completely full, that can go wrong. If the file name's incorrect, that can go wrong. If it fails to upload, that apparently can go wrong a lot. So, what my program does, because I think I'm being clever, is I catch the exceptions, return false, and if it works, I return true. So any of these guys blows up, we go to here, we send a false back. It gets to the end without blowing up, we go past the catch, and we return true. So that's how I save an account. Is everyone okay with that? If I add an overdraft value, what happens to save? If I add an overdraft value, what happens to the save method? So my account now contains a value called overdraft. What has to happen in save? Bearing in mind I'm kind of keen to know what the overdraft method is, I would add another line. Is that okay? So every single thing that's inside the account we write out on a line of its own. There's one other thing. If Robert was making this into a product he wanted to ship, there's one other thing which I would add, and I'll give a green piece of cheese to the person that tells me what this is. What's the other thing I should put inside my account that's really good and worth a green piece of cheese? Interest? Yeah. I'm thinking not in terms of managing the actual account of a customer. I'm thinking about how my program should work. Yeah, this is all to do with the bank. I'm not thinking about the bank. I'm thinking in terms of how I'm going to manage my account data in my bank going forwards. Yeah? A what? Timestamp? Yeah, that's the kind of, you're in the right direction. What happens? Say again? A history? Close. Number of records? Wrong. Change log? Close-ish. Pardon? A what? A backup? No. A what? No.
An explanation for what's failed.
No. What happens to programs over time? What's going to happen to my program when I've shipped version 1? What's going to happen to my program after version 1's gone out? Shh. What happens? Do I stop at version 1? We have this theory that Microsoft and Apple and Google and all these guys have a big book somewhere they keep in a safe under a mountain. And inside there's basically what each new version of their software will contain planned into the future. We had a person, in fact, Careers and Appointments Fair tomorrow. Go along. If you haven't signed up, doesn't matter, go along anyway. We had a chap come along who works for a big company in Hull, and they do all the packaging design for lots of companies around the world, all the really big ones, L'Oreal, Gillette, all these. They said that the Gillette people, you know the Gillette razor with 5 blades, or whatever it is this week, it's got 60 blades, I don't know. The Gillette have actually got their product plan for the next 3 versions of the razor pretty much locked down. So they know what the new Gillette razor next year will have, and the one after that, and the one after that. And we think that Apple and Microsoft and whatnot have got the next 3 versions of their products lined up as well. So if I'm playing that game, what needs to be in the account when I'm saving it? Version number. Who said that? Is that you? Good man, you had a piece of cheese for that. What I do, and this is extremely important, and it's something which, there you go, have a piece of cream cheese. Not many of those in the world. I will put a version number in there as well, so that when version 2 of the software comes out, which also contains, well, say the bank discovers there's a correlation between shoe size and thriftiness, okay? Maybe the bank decides that people with big feet save more money to pay for the big shoes. I have no idea, this is all surmise. That means all clowns are trustworthy. Not sure about that, moving on. But the bank says we must store the shoe size of all our customers in version 2. So version 2 comes along, you put shoe size into the bank account data, but version 1 doesn't have shoe size in it. You have to have a way of managing the fact that you've now got 2 sets of account records. Some of them have got shoe size in, some of them haven't. And the way to deal with that is to have the first thing you write out from your save, the version number of the account that you're storing. So when you make a new version of the program, you can bring it back. Figure out it's the old version, add a shoe size value or something and move it forward. Now you see this, I see this in save games. You get a new version of the game comes down the network and you find that your old game saves don't work. You'd be kind of cross. And the best way to handle that is to have a piece of data inside the save that you make that basically says this is version 1 or this is version 2, and then my load behavior knows what to do. Does that make sense? Otherwise you end up with a thing which is extremely brittle, and if you change it, it means that all your old data is instantly invalid, which is, yeah, kind of annoying. So, does that make sense? Let's move on. Save into aStream, yeah, we've done this. I give it the text out to write to. That's the top line here. So it just puts its information on the end of the stream. And yeah, have we made a mistake? No, we haven't, because this is my code. This is the code that saves to a file. And this one basically opens the file, calls the save. If it likes the save, it closes the file and returns true, otherwise it returns false. We can use, I'm getting bored with that, but I'm not sure how I can stop it. Pardon? Turn off the Wi-Fi, that's why it's complaining. I think, I don't know. Anyway, can you see how that would work? It's basically exactly the same as this. Make myself a stream writer, call the method to save it, close it. So it's that code. Okay? I don't mind that, that works for me. Make myself a stream writer, call the save method, close it if it's worked. That's all good and fine and dandy. And if it didn't work, I return false. Fine. Excellent. If you look in the C# definition, we've got effectively what's called overloading going on here. I've got 2 versions of save. One saves to a file, other saves to a stream. And that's absolutely fine. I'm being quite clever because I'm using different methods to do different parts of the transaction, and I'm actually quite happy with that. And there goes another one. Okay, I'm going to have a lot of things to sort out. Jolly good and fine. But I don't like this bit. I don't like catching exceptions that are thrown and hiding the fact that something bad has happened. This is not really a good way to work. I've kind of mentioned it this way to sort of think in terms of how you can deal with errors. I don't like the fact that the person doing the save has to see whether it worked or not. I'm not keen on that, because that means if they ignore what the save method returns, they might think the save had worked okay when it hadn't. if I catch an exception, I'm hiding something bad. It's a bit like when I hide bank statements at home, so my wife doesn't know that I bought another camera. Not that I ever do that, but if I did, that's what it would be like. I would much rather have the program explode and leave my core to pick up the pieces than hide the error from the person calling it. If they call my save method with a stupid file name, I want them to really suffer, okay, and not have me do something which is kind of, well, I'm going to send you false and see if you deal with that. I want the thing to blow up big time, and so I reckon that this is a much better save method. No tries, no catches, no nothing, just if it works, it works, and if it doesn't, well, you can pick the pieces up and deal with that. Because I'm really worried that people might think my save has worked when it hasn't. And this basically means that my code gets simpler, the problem is put in the right place, and if it blows up, at least that means the user won't think a thing is saved when really it hasn't done. I hate it when users think things have worked when they haven't. That's one of my bugbears. So I'm going to actually make sure that my programs just blow up when bad things happen, and that's the end of it. Does that kind of make sense? I'd rather know the bad news than have something hide it from me. And catching exceptions and returning flag values is a bad policy as far as I'm concerned. This is Robert's simple save. Open the output thing, save it, close it. The problem with this, which I don't like, and this is proper programming. This is this is good. I like doing this. If this guy blows up, if text out decides to explode, then we never get as far as the close, do we? But the file might be left open, which worries me. Don't like leaving files open. So what I like to do is sort of make sure that when I open a file, I definitely close it. If that guy blows up, then we don't get as far as the close and the file is left dangling. And dangling streams are a problem. You must have had that experience. You try and eject your... Actually, no, your students, you don't do this, do you? Whenever someone comes to see me and plugs their USB key into my machine, which is a very brave thing of me to do, it always says, this drive has errors, please do scan and fix. You've seen that a lot? That's because you just go and walk away rather than actually doing the eject behavior under Windows. Do you know about the eject behavior under Windows? And then when it says it's safe to remove, you unplug it. That's what Robert does, but other folk don't. Sometimes you try and do the eject and it says files on this device are in use, and you can't find any files anywhere that are in use. It usually means, what it means is you've been running Word at some point in the past, which has grabbed a file and not let go of it, because Word's a bit like that, which is annoying. So I didn't write Word, obviously, because you shouldn't have files that are open that are just dangling there. You should close the file because otherwise other programs can't use it and you might have things locked. And so this is my absolutely perfect proper file save, which I really, really like. Try and write the file. If it blows up, we get an exception thrown, and I throw it again. So, yeah, okay. Does that look stupid? Yes, no, whatever. It only looks stupid if you don't know what finally does. Finally is really important. And it's terribly useful. And the bottom bullet point here, the bottom bullet point here is the thing I want you to take away, really, that we know why we do try catch. We do this because there's something in here that's potentially explosive. Something in here could blow up. Writing to files is a dangerous business, okay? If it blows up, I'd kind of like to deal with that in some kind of managed way. But actually know, I want to pass the problem on to somebody else. This is a bit like telling my boss something bad has happened and making him deal with it. Okay? The reason why I like finally is that finally is guaranteed to run whether or not the exception is thrown. So the sequence will be, we'll try and do the thing. If it fails, we go in the exception handler and we rethrow the exception, which is fine. But whether we do this bit or we just keep going straight on, this line here, the finally clause is always behaved, so it performed, which means that I always do this statement here, always. So this statement here is performed whatever happens inside the try behavior. And that's kind of important to me because that's how I make sure that the file, if it's open, if it's open, we try and close it. And that happens irrespective of whether the writing process works or not. And I love that. That works very well for me because that means that there's no way I can leave the file open, or at least if it does happen that way, it's something which is sort of totally weird and outside my domain completely. So, a bit of a digression from writing accounts and banks and things, but I think it was a worthwhile one. Anyone got any questions on that? Yeah?
You know the save function?
Yeah?
Say if it performs the first two lines and blow up on the third line.
Third line being?
No, in the save text cell.
Oh yeah, going back here.
If it was writing, so if it wrote, for example, the first two,
Yep.
and then exploded on the third one,
Yep.
when the file closes, does it have the two lines that are being written, or does it have what was originally in there?
Question is, what happens if we blow up halfway through in terms of the data? I think, in my experience, if it blows up halfway through, you can't make any assumptions about what's there. The buffer, the way that disk writing actually occurs, it fills a buffer full of stuff and then writes it to the disk, fills another buffer full of stuff and writes it to the disk. The reason why you have a close is also so the buffers get flushed and written to the disk. So if you blow up halfway through, it really depends on when the buffer was last flushed, what you get, if anything. So as far as I'm concerned, the important thing is that something should just go bing bong, we couldn't write this, and you'll know that that write has actually gone south for the winter. So as far as we're concerned, if it blows up in the process, then we don't know where. I'm more concerned here with just making sure that the file isn't blocked for somebody else to use. I don't use up any of my file handles and leave them committed, and I close the file every time. So that's what I'm after. Moving on. All right? Yep, excellent. Yep, you can rethrow exceptions. It's a good plan to do that because it provides the caller with a chance of dealing with what went wrong in a managed way. So I put a try catch in the message box. That's how I would do it. So the user knows that something bad's happened, and rethrowing things is absolutely fine. I have to do that because I want to get the finally behavior in on the act. If you don't want to rethrow the exception, you can do try finally, which just basically gives the behavior that's guaranteed to run whether the exception gets caught or not. In fact, you might just leave that out and it might just work. So, this is what my code does. This is kind of sweet, I like this. So when I call save, and I do this guy, do the save down here, it prints out 5 Rob Hull 100. That means he's got, well, what does it mean? Let's have a look. But go back, go on, go back, you can do it. No, go back. Ha. Keep going back. First thing I write out is the account number, I think. Yeah, account number goes out first, followed by the name, the address, and the balance. So go back here, and there you go. Account number 5, name of Rob, address of Hull, and balance of 100. And each of those gets placed on a separate line in the file, and that's just a text file. Anyone can look at it. and that will just have the account information in it. So that's how we save stuff, and it's a really good point. I think probably just let's keep going further. No, we'll do loading next time. So any questions about saving? Yeah?
Does the save function you showed us, does that clear the file if it already exists and then write to it, or does it append the file?
Oh, that's a good question. The question is, when I open a file, does it actually append to the file or write on top? Turns out that if you open a file for writing, you clobber what's in there magically. So this is potentially dangerous. It means that if you are not careful, you could overwrite a good file with bad data. Word has this behavior where it says, if you do a save as on top of an existing file, Word says, do you want to overwrite this file? Now, you can put that behavior into your program, but by default, if you open a file that exists, you tromp all over it. It doesn't, there is a write mode you can engage where you open the file for append to the end of it, but that's not what we've got here. What we've got here just opens it and whacks a whole new one in there and destroys the older one, which can be kind of irritating. In the case of the bank, we do want to overwrite it. In the case of the other programs, you might not want to. Yeah, question?
With the save function, when you save in the variables,
Yeah.
does it say which like say you save the variables, does it remember which variable is which when you try to load it?
Does it remember which variables which? Absolutely not.
So how would you try and load them?
How do you load it back? You load it back in the same sequence. I have to make sure that when I do my load, I read in the account number, the name, the address, and the balance. If I read things in the wrong sequence, I'll get guacamole coming back at me. That's why XML is so nice, because XML has a name for all the elements. I'm using positional, which is not particularly clever, but it's dead simple to implement. Yeah. Anything else? Okay, I'll see you folk in a couple of hours.